So by doing just the check of the question without actually doing the work would have given us the right answer in this case. Our answer is 6 because 6 checked and -1 did not check. And those were, again, the only choices they had. Now I'm going to go back and look at this problem as if it is not a multiple choice, but an open-ended question. In other words, what if you got this question on Delta Math and you had to work it out? So how do we work out such a problem? So again, let's remind ourselves, when we have a radical equation, the first thing we have to do is isolate the radical. Just like when we have an absolute value equation, we isolate the absolute value. Here we isolate the radical. We get the radical by itself by subtracting 2 from both sides. So on the left side, I get the square root of x plus 10. And on the other side, I get x minus 2. I can't combine these because they're not like terms. And then we use our basic rule in solving radical equations. We square both sides. We square both sides because when we square a radical, it removes the radical sign. In other words, when I square the square root of x plus 10, this side, all I'm left with is the x plus 10. It's always easiest to do the squaring of the radical because all it's doing is basically erasing the radical. But the other side is x minus 2 squared, and that's not in a radical. So I actually have to multiply the x minus 2 times the x minus 2. I have to square that. So this stays x plus 10, and this becomes x squared. I'm doing FOIL. Outer is negative 2x, inner is negative 2x, and negative 2 negative 2 is positive 4. And of course, that makes this into a quadratic equation. And when we want to solve a quadratic equation, we want to make sure everything is equal to 0. So that means I'm going to have to subtract x from both sides. And I'm going to have to subtract 10 from both sides so that I'm taking it away from the smaller side. So on this side, I'm left with 0. And on this side, I'm left with an x squared. I'm going to count all these up. This is a negative 2x, and negative 2x is negative 4x, plus another negative x. So altogether, I have negative 5x. And this is plus 4 and negative 10, which is negative 6. And now I'm going to factor this. And that's going to factor to x and x. And my last term is negative, so one is positive and one is negative. And we need two numbers that multiply to 6 and subtract to 5. That has to be 6 and 1. And the larger number is the 6 has to go with a minus because the middle term is minus, and the 1 goes with the plus, which gives us, as our two answers, x plus of 1 equal to 0. So that gives me x equals negative 1. And x minus 6 equal to 0. That gives me x equal to 6. So it gives me the two answers, negative 1 and 6. Now, if you stop right here and you don't do the check, you're not going to get it right because you have to check. Radical equations must be checked. Notice we did the check before. We saw that the 6 did work, but the negative 1 did not, because when I put in negative 1, I got, on one side, I got 3 plus 2, which is 5, and on the other side, I got negative 1. So this answer would have to be thrown out, and the only correct answer is x equal to 6. Notice all this work was done to see the two possible answers, which were 6 and negative 1. But the check must be done. So when you're doing this as a multiple choice, save yourself the time. Make sure you just do the check, because you're going to have to do the check anyhow. And the answers that are in the multiple choice are the only answers that make sense, because you have to pick from those answers. Does anybody have any questions they want to ask me about this? Okay, I'm glad to see everybody here now. Okay, let's go on to some new material then. This was, we so far in this chapter, we've learned how to add, subtract, multiply, divide, and solve equations with radicals. So there are two things I want to talk about. First of all, I want to talk about something called fractional exponents. Up until now, we've talked about three types of exponents. We talked about having regular exponents, like if I just had regular whole numbers, like if I did 4 to the third. I know what that 3 as an exponent means. It means multiply 4 3 times. And of course, your answer would be 64. That's the type of exponent that we're first introduced to, probably back in elementary school as well. Then we talked about here, what happens if we have a 0 exponent? And we said no matter what, when we have a 0 exponent, our answer is going to be 1. 4 to the 0 is 1, 7,000, 6 x fourth, all to the 0 power. Doesn't matter what it is, this is going to give us 1. Anything to the 0 power is equal to 1. And then we talked about negative exponents. So if I saw something like 4 to the negative 2, if you remember what I said you should do, is that negative doesn't tell you the answer is going to be negative. It tells you you're taking the reciprocal. In other words, this is really a fraction, 4 to the negative 2 over 1. If you don't see every number can be written over 1. When you have a negative exponent, it tells you to take the reciprocal, which means if your number's in the numerator, you bring it to the denominator. And if your number's in the denominator, you bring it up to the numerator. In other words, we move the 4 to the negative 2 to the denominator. We're not left with 0 in the top, we're left with 1. Anytime everything disappears, you're left with 1, because you're not subtracting, you're really dividing, you're canceling. And 1 over 4 squared means 1 over 16. So these are the different types of exponents that we talked about. We talked also about all the rules that apply to exponents. In other words, when you multiply two numbers that have the same base, then you add the exponents, you distribute. All the rules that apply to exponents apply to whole positive number exponents, 0 exponents, negative exponents. And now I want to talk about another type of exponent. What if I gave you something like this? suppose I gave you 4 to the 1/2 power. What does it mean when we have a fraction as an exponent? Now, it can't mean I'm multiplying 4 1/2 times. It doesn't mean I'm multiplying 4 by 1/2 either, because it's not, you're not multiplying these together. The 1/2 is an exponent. So I'm going to show you something, and I'm going to add, because I'm going to, it's going to give you an understanding as to why we do what we do with fractional exponents. What if I had taken 4 to the 1/2 and multiplied it by 4 to the 1/2? Well, remember, these are exponents, so we just use our rules of exponents. Our two bases are the same, they're both 4. So when we're multiplying two numbers with the same base, what we do is we add their exponents. So we get 4 to the 1/2 plus 1/2. And we know 1/2 plus 1/2 is 1. So this really means 4 to the 1, which is simply 4. So what is this telling me? It's telling me that when I'm multiplying 4 to the 1/2 times 4 to the 1/2, my answer is going to be equal to 4. Now let's think, what two numbers, these are two numbers that are the same, what two numbers can we multiply together to give us 4? Well, obviously it would have to be the square root of 4 times the square root of 4. Sorry, it's on X. Because I know when I multiply a number by a square root by itself, it just gives me the number that's inside the square root. In other words, it seems to me that it makes sense that 4 to the 1/2 should really mean the square root of 4. Or in general, x to the 1/2 means the square root of x. And we can expand this definition to say that any time we have a fractional exponent where the numerator of the fraction is 1, then in other words, if I have x to the 1/3, that's the same thing as saying the cube root of x. Any fractional exponent really is a radical, and the denominator, the number that's in the denominator of the fraction, is the index of the radical. So how does that work out? Well, let's see some problems. Suppose I ask you to figure out what 81 to the -1/2 is. I'm going to do one, then I'm going to give you a couple to try. There are two things going on here. There's a fractional exponent, and there's also a negative exponent. And these each tell us different things. The negative tells us to take the reciprocal, which means here is my fraction. This is really over 1 because it's nothing, it's over nothing, it must be over 1. We're going to put that in the denominator and make it 81 to the +1/2. Of course, that leaves my numerator to be 1. In other words, I take the reciprocal of the 81, which is 1 over 81, and make the exponent positive. And then I think, what does the 1/2 exponent mean? Oh, I just said the 1/2 exponent is the same as the square root. This is the same as saying 1 over the square root of 81. And we know what the square root of 81 is, that's 9. So my final answer becomes 1/9. Notice with the exponent, we're able to indicate two things that we want to do. We're able to indicate, since it's a 1/2 exponent, that we're taking the square root, and that the negative is telling me that I want to take the reciprocal. Here's another problem. Um, 64 to the 1/3 power. What do we mean by asking what is 64 to the 1/3 power? Well, remember we said the 1/2 power means a square root. The 1/3 exponent means the radical, but now the index is 3. Remember, when we're taking the square root, we don't write in, the index is understood to be 2, but we don't write it in, we just write in plain square root. But any other root, when we want to use the radical sign, we have to put in the index. The index in this case would have to be 3. So this means that we want to do the cube root or third root of 64. And the cube root of 64 is what number times itself 3 times will give me 64. That has to be equal to 4. It's not 8, because 8 times 8 gives me 4, but I want to multiply 3 times. 4 times 4 is 16, and 16 times 4 is 64. If you don't know it, of course you can do it on your calculator. If you have your calculator, it's very easy to do 64 to the 1/3 power. What you put in is you put in your 64 and you press what is your exponent button, because this 1/3 is an exponent. Usually the exponent button looks like a button with an arrow pointing up. If you can't think, otherwise it might look like this also. It might be a button where it has a Y with an X exponent, something like this. These are what are called the exponent buttons. Most of the newer calculators, scientific calculators, use this. I'm sure some of you, when you're typing, have used that button. That little upside down V is the exponent button. You press it, and now you want to put in 1/3. Now 1/3 is, the way we put in 1/3 is 1 divided by 3. Now notice I put it in parentheses. The reason is because if I don't put in parentheses, the calculator thinks that the only thing I want is the exponent is the 1 and divide the whole answer by 3. That's not what I want. I want the exponent to be 1/3, which is 1 divided by 3. Anytime I'm using my exponent, an exponent that's more than just a single number, I have to put it in parentheses. Now, if you do that, now those of you who have your calculators, you will see when you press equal, you will get 4. So you definitely can use your calculator for fractional exponents, and the answers are going to be given to you pretty exactly. Most of these I'm going to do using just using my head, but again, you could do it using the calculator. Now, what about something like this? What if I had an exponent like this? Suppose I asked you to do 27 to the 2/3 power. What does it mean when my exponent is a fraction, but the top of the exponent, the numerator, isn't 1? Well, if you think about it, 2/3 really means 1/3 times 2. Any fraction, 7/12, really really means 1 over the denominator, 1 over 12 times the numerator. 3/4 could be also written as 1/4 times 3. So when I look at this 27 to the 2/3, what it really means is 27 to the 1/3 times 2 exponent. That's what 2/3 is. It's 1/3 times 2. Now, I can put this in parentheses. What does that mean? It means that when I'm doing this, I really have to do 27 to the 1/3, which means do the cube root of 27, which happens to be the number 3. That's your first thing. In other words, deal with the denominator. The denominator is telling you the index is 3. That means you're doing the third root or cube root of 27, which is 3, because 3 times 3 times 3 is 27. And then you have this other exponent of 2. You have to do that second. So now you have to do the answer, which we got, which was 3, and square it, which will give us 9. So my final answer to this is 9. Of course, you could do it on your calculator. And on your calculator, you don't have to really think too much. You just put it into your calculator the way it states. In other words, if you want to do 27 to the 2/3, you're going to do 27. You're going to press your exponent button. And since your exponent is a fraction, you have to put it in parentheses. You're going to do parentheses 2 divided by 3, and close your parentheses and press equal or enter, and your answer will come out to be 9. Again, the 2/3 exponent is telling you to do 2 things. The 3 in the denominator of the exponent is telling you you're doing the cube root. The 2 in the numerator is telling you you're doing it to the second power. So you're doing the cube root and then you're squaring it. Then you're multiplying it by itself. Let's see if I can find a problem on a exam. Looking at an old exam and seeing if I'm finding any sort of problem that's similar, and of course I'm not, because they don't come up on every single exam. All right, so look at one more, and if I don't find it, then I'll make one up myself. What if I gave you a question like this? Figure out what 81 to the negative 3 halves is. I'm going to give you a few minutes to try this on your own. I'm going to take attendance while you're doing this. And you can try it. If you have a calculator, you could use your calculator and see if you come up with a good answer with your calculator. Okay, I'm going to pause the Okay, so let's see if we can do this first, just trying to figure it out, and then we'll think what would happen if we put it into our calculator. Now, 81 to the -3/2. There are a lot of things going on here. Number one, it's telling me that I'm doing a negative exponent. The negative exponent tells me I have to put 1 over my number and make the exponent positive. I have to take the reciprocal. So this really means 1 over 81 to the +3/2. Now, again, the fact that the exponent is a fraction is telling me that I'm doing two things. I'm doing 81 to the 1/2 power, and then I'm doing it to the 3, because 1/2 times 3 will give me the 3/2. In other words, the 3/2 power is telling me to do two things. It's first telling me to do the 1/2 power, which means take the square root of 81, which is 9. And then I'll then do 1 over 9 to the 3rd. Now, 9 to the 3rd, I'm going to take out my calculator to do that. Nine to the exponent of 3 gives me 729. So this becomes 1 over 729. And that would be the answer to this question. That's doing it really by figuring it out. I know I use my calculator a little bit, but just to multiply 9 times 9 times 9. What is the other way I could have done it? Well, when I have a negative exponent, the first thing I'm going to do is I'm going to remember what the negative exponent means. It means to put it into the denominator. And then I'm not going to put 1 over. I'm just going to do the 81 to the 2/3 power on my calculator. Because otherwise I'm going to get a decimal, and I don't want a decimal. I want a fraction. So I'm going to do in my calculator 81. Then I'm going to press my exponent button, and then I'm going to do parentheses 2 divided by 3. Then when I do that on my calculator, 81 to the exponent, parentheses 2 divided by 3, gives me, oh, I'm sorry, it's not 2, I'm messing you up. The exponent is 3 over 2. I don't know why I'm saying it's 2 over 3. It's 3 over 2. The minus only takes the reciprocal of the number. It doesn't take the reciprocal of the exponent. We want to do 1 over 81 to the +3/2. So in my calculator, I'm going to do 81 to the 3 divided by 2. So 81 exponent 3 divided by 2. Don't forget the parentheses. And that gives me 729 on my calculator. So my answer is 1 over the 729. So I could use my calculator to simplify some of the work there. Again, the negative exponent means take the reciprocal of the base, the number that has the exponent, not the reciprocal of the exponent. Okay, one more for you to try. What if I gave you this question? See if you can come up with the answer. Give you a couple of minutes. Again, you could do it either mentally or you could try it on your calculator. It says evaluate 64 over 27 to the negative 1/3 power. See if you can come up with something like that. And Teresa, I did not mark you absent. So I don't know if I called your name. I must have realized you're here. Okay, let's see if we can work this out. Now, I'm going to do this in my head. If I use my calculator, I don't like to do the whole thing to the calculator because it'll give me an answer in decimals, and that won't be the, if it's a multiple choice question, it won't give me an answer in decimals, they'll give me an answer in fractions. So part of the work I always do by myself. First of all, remembering the rules. When we have a fraction with an exponent, it means that that exponent is being distributed to everything inside the parentheses, which means that 64 is to the negative 1/3 power, and the 27 is also to the negative 1/3 power. So anytime you have a exponent outside of parentheses, it means apply that exponent to both or to all the different things that are inside the parentheses. I also remember that when I have negative exponents, remember I'm doing all the regular rules of exponents. A negative exponent tells me to take the reciprocal of a number, which means if it's in the numerator, I put it in the denominator and make the exponent positive. So that'll mean 64 to the 1/3 in the denominator. The 27 to the negative 1/3, that's in the denominator. Since its exponent is negative, it's going to have to come up to the numerator. In other words, I've basically taken the reciprocal. Also, I now have to do the 1/3 exponent. Now, the 1/3 exponent means the third root, the cube root of 27. What number times itself 3 times will give me 27? Obviously, that answer is 3. And the cube 64 to the 1/3 means the cube root of 64. That means what number times itself 3 times will give me 64, and that's 4. So my answer to this question is 3/4. Notice this one exponent tells you to do a lot of things. The negative, take the reciprocal. The 1/3 means take the cube root. So you can do a lot with just a single exponent. You can say a lot of things with it. Here's a question that was on a final. This is going to be a multiple choice question. It says evaluate 27 to the 1/9 to the with a 3 on the outside. And your choices are A, -3, B, 3, C, 27, D, 9. See which answer you come up with. I'm going to give you a couple of minutes. Okay, I'm erasing this so I can work on it. One way is just stick it into my calculator. How would I stick it into my calculator? Well, here's what I would do. I would write it exactly the way, see here. I put in my 27 in a parentheses. I want to do the exponent, remember, so I then have to press my exponent button. And then I have to do 1 divided by 9. And then close that parentheses, because I'm up to here. And now I want to do the exponent again. And now the exponent is just 3. Since it's a single number, you don't have to put that in parentheses. And if I do that on my calculator, I get 27 parentheses. I'm writing it exactly. That's the advantage of these 2-line calculators. The way you see it on your paper, that's the way you enter it on your calculator. So parentheses 27, press my exponent button. I put in parentheses 1 divided by 9, and I close that parentheses. And then I close my original parentheses. I'm up to here. I press my exponent button again, and I put in 3. And when I do that, my answer comes out to be 3, which is choice B. Let's see what people got as their answer. I see, yes, both Evelyn and Nikisha got those answers. Great. What if I didn't want to do it with my calculator? What if I wanted to figure it out in my head? So how would I do this? I certainly have no way of doing 27 to the 1/9 power. The 1/9 power means what number 9 times will give me 27. I don't know any such number, but I know when I have 2 exponents on a number, I have 27 to the 1/9 to the 3rd power, I can multiply those 2 exponents together. In other words, that's the same as saying 27 to the 1/9 times 3, because according to the rules of exponents, when you have 2 exponents on a number, it means that you're multiplying the 2 exponents together. Now, 1/9 times 3 is 3/9, which is the same as saying 27, 3/9 to the 1/3. So saying this 27 to the 1/9 to the 3rd power is the same as saying 27 to the 1/3 power. And that means take the cube root, the 3rd root of 27. What number times itself 3 times will give us 27? And that answer is 3. So again, I could either do it using my calculator, or I can do it in my head, but I come up with the same answer, choice B. So we're going to see at various times during the term, we will come across places where we'll have fractional exponents. The most common fractional exponent that you'll see is 1/2. So x to the 1/2, that's the most important one to remember, is the same thing as saying the square root of x. Again, it can be used for any root, but a fractional exponent is really telling you to do a root. And the 1/2 exponent is telling you to do the square root, just like the 1/3 exponent is telling you to do the cube root or the third root. Okay, let's go on to the last topic that we're going to see in this chapter. And that's something called complex or imaginary numbers. I know if I use the word imaginary numbers, you're saying, oh, this is something she made up. It's a figment of her imagination. Those things don't really exist. And that's not really true. As a matter of fact, there are uses of these special numbers called imaginary numbers in real life situations. In electrical engineering, they're used a lot. There are places where they are used. The only reason they're called imaginary numbers is because the numbers that we use on a regular basis, the numbers that are on our number line, are called the real numbers. And this is not a real number. So if something not a real number, what should I call it? So they said, let's call it imaginary. Okay, what is an imaginary number? Well, if you recall, when we started talking about square roots, the one thing I said you can't do is to take the square root of a negative number, because there's no real number that when you multiply it by itself will give you -25. Real numbers are either positive or they're negative. A positive times a positive is always positive. A negative times a negative is always positive. So it's impossible in the real number system, in the number system that we use on a regular daily basis, it is not possible to get the square root of a negative number. And if you come up with an answer like this, it's very true to say there's no solution. There's no solution in the real number system. But for a little bit, we're going to talk about a number system that's called the imaginary number system, which is the regular numbers that we're dealing with, in addition to one extra number. That number is the number that we call I. Now, if you notice, I'm using as my I a lowercase I. And I'm not writing the lowercase I like this. And the reason I'm not doing that is because if I write it like this, you're very likely not to see the dot on top. And if you don't see the dot, you'll just think I wrote a 1. So whenever I write the lowercase I either write it like this with a little hook, or sometimes I write it as a script I. This is my new number. Now, what is this new number equal to? This new number is the square root of -1. Doesn't exist in the real number system. It only exists in this new complex or imaginary number system. If I have this one extra number, I can write any square root of any number with a negative in it. Because if I have the square root of -25, I can break that down into the square root of 25 times the square root of -1. And the square root of 25 I know is 5. And the square root of -1 is this new number that I'm calling I. So 5i is the answer to the square root of -25. Whenever I'm going to be working with these numbers, I'll tell you give your answer in terms of I or give your answers as in A plus BI form, I'll somehow mention that I want something with an I in it. As soon as you hear or see the letter I, this little script I, that's telling you that we're working not in the real number system, but in the expanded number system that includes this additional number that we, I, which is the square root of -1. Now, let's see how we work out problems with this new number I. Well, first of all, anytime I'm going to have a square root with a negative in the inside the radical, it's not outside, it's the radical inside, I'm going to right away break it up into a positive number, in this case 36, and -1. And the square root of 36 we know is 6, so this becomes 6i. If I have something like the square root of -50, again, there's that negative. I'm going to break it up into the square root of 25, because 50 is 25 and 2, times the square root of -1. In other words, I now have an additional, instead of just having 25 and 2, I also have this -1. And the square root of 25 is 5. So this becomes the square root of 5 radical 2i. Most likely, you will not see it written this way. When you have something that has a radical in its answer, they're afraid that you're going to draw this line too long and it'll look like the I is inside the radical. So the better way to write this is 5i radical 2. In other words, you're just multiplying 3 things. When you're multiplying 3 things, it doesn't matter which order you're multiplying it by. Always put the radical at the end. So the square root of -50 would be written as 5i radical 2. And I do it so it shouldn't look like that I is inside the radical. If you're not careful, if you're a little sloppy, that line gets too long and it looks, is the I inside the radical, is the I outside? So put it in front, then it's obvious it's not inside the radical. All right. Now, what do we have to do with these imaginary numbers? Well, the same things we did with all of the things that we've been dealing with when we talked about polynomials. We talked about adding, subtracting, multiplying, and dividing polynomials. When we talked about radicals, what did we talk about? We talked about adding, subtracting, multiplying, and dividing radicals. So when we talk about imaginary numbers, we're going to do the same thing. How do we, of course, we've talked about simplifying them, but how do we add, subtract, multiply, and divide things that have i's in them? How do we deal with combining these imaginary numbers? And you're going to see it's going to be the regular rules of algebra that we've always used are going to apply to these new numbers as well. In other words, if I were to tell you that I want you to add the square root of -25 plus the square root of -81, the first thing is that your 2 radicals, you can't add them because they're not like radicals. In any case, you cannot work with square roots of negative numbers. You first have to write them in terms of I. Well, the square root of -25 is 25 and -1. So that gives me square root of 25, which is 5, the square root of -1, which is I. So the square root of -25, we simplify to 5i. What about the square root of -81? Well, that's multiplying 81 and -1, and the square root of 81 is 9, and the square root of -1 is our I. So this square root of negative 81 becomes 9i. And now I'm just asking you, can you add 5i plus 9i? And of course you can, they're like terms. You just add them. These are not x's, but the idea is the same. 9 and 5 and 9 is 14, so your final answer becomes 14. So when you have these square roots with negatives in them, what you're first going to do is simplify them so they're written in terms of I, and then do the regular arithmetic that you would normally do with variables. These are not variables, but the rules are the same. Let's say I gave you this problem. Suppose I gave you this problem. 3 minus 5i minus 3 plus 6i. Combine these and give me your answer in simplest format that you can. Okay, let's do this. Think of your I just like an X. In other words, you're going to do the same thing to your expressions as if this is just something with a variable. I is not a variable, it has a specific value. But the way we work it is the same we've always worked. We want to combine. Think of this as if it's a minus 1. Remove the parentheses, so this becomes 3 minus 5i. Negative 1 times 3 is negative 3. And negative 1 times 6i is negative 6i. And now combine the like terms, which means add the numbers that don't have any i's. So 3 and negative 3 just cancel out. And then add the variables that have i's. Negative 5i minus 6i is minus 11i. By the way, you cannot simplify 3 minus 5i. This is what we call a complex number. A complex number is a combination of a real part, something that doesn't have an I, with something that does. 3 minus 5i is a complex number. Negative 11i, which just has i's in it, is imaginary. If I give you a number like plain 15 without any i's, this is real. So this type of number is real. It doesn't have any i's. This kind of number is imaginary because it has only i's. It's negative 11 i's. And something like 3 plus 6i, which is a combination of real parts and an imaginary part, is what we call a complex number. And most of our answers are going to be complex numbers. Most of our answers, after we work them out, it's going to have probably some real part and some imaginary part. We can't combine them because it's like adding 3 and 6x. They're not like terms. But adding and subtracting of complex numbers or of imaginary numbers is exactly what you expect it to be. You just work it just like we did when we were working with polynomials. What about multiplying? Well, let's start with an easy one. Suppose I gave you 3i times 7i. In other words, I just have imaginary numbers that I'm multiplying. First, we'll start with imaginary, then we'll start with complex. Well, according to the algebra, 3i times 7i should be 21i squared. And it's this I squared that I want to take a look at. Remember, I stands for the square root of -1. So I squared means the square root of -1 squared, which is the square root of -1 times the square root of -1. And we know when we're multiplying a radical by itself, what you're getting is what's inside the radical. This will give you -1. Remember, we did this before when I said if we had the square root of 3 times the square root of 3, that just gave us 3. And remember, that was our shortcut. We don't have to do the square root of 9, which is 3. The same thing, the square root of -1 times the square root of 1 is simply -1. So anytime I come across an I squared, my I squared can be replaced with the regular number -1. I squared is a real number. I squared, this is the most important thing that you're going to have to remember. I squared equals -1. I is not real. I you have to leave. You don't want to replace I with the square root of -1 because it has a radical in it. But I squared is a real number because it has no radical in it. So if I come up with an answer that says 21i squared, what I'm going to do is I see an I squared. Anytime I see an I squared, I'm going to replace it with a -1. So this means 21 times -1. So my answer over here would be -21. It is perfectly possible to multiply two imaginary numbers, and your answer is not an imaginary number. Your answer is a real number because a real number doesn't have any i's in it. Remember, every time you see an I squared, you're going to replace it with a -1. That's the most important thing to remember about this whole process because everything else works exactly like you've always worked with the variables and with algebra. All the rules are the same. Only if you see an I squared, replace I squared with -1. You can't do that with x squared because x squared, you know what x is. But I, we know is the square root of -1. We actually know what the I is. It's not a variable, it's an actual number. And I squared is equal to -1. Now, what happens here? I just multiply two imaginary numbers. What if I wanted to multiply two complex numbers? Let's say I'm going to do one, then I'm going to give you one to try. Suppose I wanted to multiply 3 plus 5i times 7 minus 2i. 3 plus 5i is a complex number because it's a combination of a real part, which is 3, and an imaginary part, which is 5i. Same thing with 7 minus 2i. My real part is 7. My -2i is my imaginary part. So that makes it complex. How do I multiply these two? Well, these are binomials. So when we multiply binomials, we use FOIL. So that's exactly what I'm going to do. 3 times 7 will give me 21. Outer will be 3 times -2i, which is -6i. There's nothing difficult about this because it's just like regular algebra. 5i times 7 is 35i. And finally, 5i times negative 2i is negative 10. Don't forget, I times I gives me I squared. And here's the only thing I really have to do before I simplify. I see an I squared. The i's I leave it alone, but the I squared I replace by a negative 1. So this becomes negative 10 times negative 1. You're multiplying this because this is negative 10 times I squared. So negative 10 times negative 1 is positive 10. And now just combine the like terms, which is the 21 and the 10, which gives you 31. The negative 6i plus 35i is plus 29i, because negative 6 and plus 35 is 29. And my answer, this is what's called the answer in A plus BI form. Usually, the way we put it is we put the real number, the one that doesn't have an I, first, and the I part second. A is 31, B is 29. This is 31 plus 29i. Notice the answer is a complex number because it has a real part and an imaginary part. But literally, the only thing that's different from this is from regular FOIL is that when you see that I squared, you have to replace it by negative 1. So let's see if I gave you this question. It says simplify and write your answers in the A plus BI form. And here's the question. I have 9 minus 5i times 5 plus 4i. And it's a multiple choice question, so I'll give you the choices. 65 minus 11i. 65 plus 11i. Negative 20i squared plus 11i minus 45 is C, and D is 25 minus 61i. Okay, I'm going to give you a few minutes to try that. Good. Okay, so I want to multiply these, so I'm going to use FOIL again. So I'll first do 9 times 5, which will give me 45. Then I'll do outer. 9 times 4i is plus 36i. Inner. Negative 5i times 5 is minus 25i. And finally, negative 5i times plus 4i. So negative 5 times 4 is negative 20. And don't forget, I times I is I squared. That's the most common mistake, is people forget that I times I gives them I squared. Notice then, I see this I squared, I'm going to replace this with a negative 1. So this is going to give me negative 20 times negative 1, which is positive 20. No I in it, because I squared is negative 1. It's not, it no longer has an I in it. So I combine the 45 and the 20, which is 65. And then I combine the 36i minus 25i. Those are like terms. 36 minus 25 is 11. So this becomes 65 plus 11i. And yes, you are correct. Teresa, the answer is choice B. Any question about that? Okay. All right. So we've now done adding, subtracting, and multiplying. Let's talk about dividing of complex numbers. How do we divide complex numbers? So let's say I have 2 plus I over 3 minus 2y. How do we deal with a fraction that has i's in it, specifically I in the denominator? Well, just like we did with our radicals, remember I is really a radical. It's an irrational number. It stands for the square root of -1. And what we really want to do is simplify this. And what we want to do by simplifying this is to make sure there's no i's in the denominator. Because that I, again, is like a radical. We don't want a square root in the denominator. We don't want an I in the denominator. Well, if you remember what we did when we had a binomial with a radical in the denominator, what we wanted to do is multiply it by its conjugate. Because when we multiply conjugates with radicals, the radicals disappear and I have just a plain, regular, real, rational number. So I'm going to do the same thing over here. When I see an I in the denominator and I have a binomial, then I'm going to multiply it by the conjugate of the binomial. Well, the conjugate of 3 minus 2i is going to be 3 plus 2i. Notice if this would have been just a single term, let's say 2i, I'd only have to multiply by the I. But when I have a binomial with an I in my denominator, I have to multiply it by its conjugate. Of course, whatever I multiply the denominator by, I multiply the numerator by that as well. Now, you remember I always like to do the denominators first. Somehow I get satisfaction from it. Also, multiplying conjugates is always easier because I know when I multiply by conjugates, I do not have to use FOIL. I can just do first and last because with conjugates, the outer and the inner always cancel out. So I'm going to multiply just the first together, 3 times 3, which is 9, and negative 2i times positive 2i, which is negative 4i squared. Don't forget I times I is I squared. Again, that I squared becomes a negative 1. So this becomes 9. Negative 4 times negative 1 is plus 4. So my denominator comes out to be the real number without any I, 13. Now I'm not finished with this problem because the numerator I have to take care of as well. And the numerator happens to be a complex number times a complex number. They are not conjugates, so I have to use the complete FOIL. I have to actually do FOIL. 2 times 3 will give me 6. Outer is 2 times 2i, which is 4i. Inner is I times 3, which is 3i. And finally, last is I times 2i, which is 2i squared. Again, don't forget, I times I gives you I squared. And then I squared is going to again be a negative 1. And positive 2 times negative 1 gives you negative 2. So if I combine my like terms, I have a 6 and a negative 2, which is 4. And 4i and 3i is 7i. So here's my real part, here's my imaginary part, the 7i. It all goes over 13. This is a perfectly good way to write the answer, though sometimes what we do is we put it in what's called A plus BI form. And what you have to do is separate it. That means put the 4 over the 13, that's your A, plus the 7i over the 13, so that's your BI. So this would be the proper format. If you're given a multiple choice, sometimes they'll give the answer in this format, sometimes they'll put it in this format. So this is division with imaginary numbers is just like the simplifying radicals, just the same format. Okay, we have a couple of minutes, so I'm going to give you one to try. Again, it's going to be off a final exam, so you'll see what it's like. Here's the example that they gave. I'm going to erase just put it over here. It says, write your answer in A plus BI form. They give you I over 2 plus I. And here are your choices. 1 over 5. 2 over 5I. 1 over 5 minus 2 over 5I. And D is 1/5 plus 2 over 5I. So I want you to simplify this and see which answer you come up with. And see if what answer we come up with. Okay, so we're going to take our question, which is I over 2 plus I. And obviously, they might say divide, they might say simplify, but the idea is just like when you see a radical in the denominator, if you see an I in the denominator, you have to rationalize that denominator. You have to have just a plain regular number in the denominator. So we're going to multiply by our conjugate of the denominator, which is 2 minus I. And whatever I do to the denominator, I'm going to do the same exact thing to the numerator. So my decision as to what I do always depends on the denominator. In the denominator, I'm going to do, and I have to do FOIL, I just have to do first and last because they're conjugates. So 2 times 2 will give me 4. And positive I times negative I will give me negative I squared. So that becomes 4, now the I squared is negative 1, minus negative 1 is 4 plus 1. So that gives me as my denominator 5. What is my numerator? Well, I have to multiply the I times 2 minus I. In this case, I don't have two binomials. I just have a monomial times a binomial. I just have to use a distributive property. So I times 2 will give me 2I. And I times negative I will give me negative I squared. And again, I see that I squared. I know that's a negative 1. So this becomes 2I. Negative times negative 1 is plus 1 over 5. Now, I don't see this answer anyplace, but remember what they told me. They said put it in A plus BI form, which means I have to separate it. So this will be 2I over 5 plus 1 over 5. And I also have to put the I term second and the plain number first. So that will be 1 over 5 plus 2i over 5. And when I look at it, it's obviously choice D. Any questions about that? So we now know how to work with these new type of numbers called imaginary numbers. Don't forget to look at your Delta math to see if there's any homework you haven't done. Please keep current. I have a due date, a first due date, which is really the date that you have to have it done by, but I've extended the due date of all these things to, I think it's the 5th of December. In that case, you don't get 100%, you get 90% of the credit, but if you didn't do some of those homeworks, go back and do them now. They should be available. If you're having trouble with any of them, just email me and I'll try to help you with your problems. Okay. Any questions before I close class? We're going to be starting chapter 7 on Thursday, which is a very important chapter, probably one of the most important chapters of this term. Okay, have a good day, everybody. I'll see you on Thursday.